we'll deal with installing ASTRA-sim and writing some simple input files and running the ASTRA-sim depending on the input file you just wrote. So to install ASTRA-sim, the first prerequisite is, can you please go to that GitHub webpage and see, let me show you. Here on the very bottom, there's this installation button. And if you click there, you can see those dependencies of ASTRA-sim. So if not installed yet, you can just download it. And once it's done, what we should do is we create a tutorials repository. We can clone it, go there and clone ASTRA-sim. So let me show you. Here's my terminal. I can clone the tutorials. So let me remove this again. Let me clone this. And then you can go tutorials and ISCA 2022. Then you can clone ASTRA-sim itself and it will just start downloading and branch to the appropriate branches. Once this is done, you can go to exercise 1 folder and start building ASTRA-sim, and it will just compile ASTRA-sim. Takes roughly some minutes. And by the way, this version of tutorial, we're cloning the analytical backend, not Gen 5, and compiling ASTRA-sim with that analytical version of the backend. Compilation on my machine is done, so let me just resume. So anyway, the takeaway is you can clone this tutorials repository, go to this ISCA folder and run this clone ASTRA-sim script and it will automatically clone. And then you can go into exercise 1 folder and build the ASTRA-sim. So this is how you download the source code and compile it. I mean, if the dependency is not working, you can pull the Docker image as well, and then go to exercise 1, just like here, and build the ASTRA-sim as well. Okay. So once this is done, what we want to do is create a simple ring with 8 MPUs and run 1 megabyte all reduce on it. So this is the 8 MPU ring. And now let's just use 500 nanoseconds as the link latency and 50 gigabytes per second as the link bandwidth. And as you can notice, each MPU has 2 links connecting it to other neighboring MPUs. So here's the network input file you generate. It only has 1 dimension, a simple ring, and it has 8 MPUs within it. And just like I said, it has 2 links connecting to other MPUs. And the latency of the link is 500 nanoseconds, and link bandwidth is 50. So this is the network input file to this analytical network backend. And the system input file, it has multiple configurations, let's say LIFO intra-chunk scheduling policy, endpoint delay is 10 nanoseconds. We're gonna split a chunk into a collective into 4 chunks, and only 1 chunk will be active at a time. But the core part is those 2 things. We're gonna split our 1 megabyte all reduce into 4 chunks, and the all reduce algorithm we want to run is ring over this algorithm, just like Tushar and Said explained before. So this is the input, like system info file we're going to give to this ASTRA-sim. And the workload file is again explained, but if you break down this, what we should give them is compute time, communication type, and communication size. Here not we are simulating any computation, so I just give it 1. And communication, I want to simulate all reduce. That's why I just set this weight gradient all reduce. And the communication size is 1 megabyte. The unit in the ASTRA-sim info file is bytes. That's why I just put this number. And the training loop we are using is micro benchmarking. We only have like 1 layer, which is just simulating this 1 megabyte all reduce. So I just pre-populated all this topology network and like system and workload file. So what you should just run is this exercise1.sh. It's nothing but it will call the ASTRA-sim binary with the 3 file we just generated, the network file, system file, and workload file. And it will save the result to the resulting directory. So here the build is done. Let me just run exercise1 script. It run ASTRA-sim. And the core part of here is, as you can see, all past finish at time 45,681, meaning as the unit is nanosecond here, so it means this 1 megabyte all reduced on 8 size ring took roughly like 46 microseconds. And also in the tutorials folder I just cloned in ISCA and exercise1, you can see this result folder being generated. I mean, it dumps a lot of logs, but for simplicity, I also dumped this tutorial result of CSV. And here you can see the result of ASTRA-sim. And as you can see, the total time taken was 45 microseconds. There were no computes. That's why every communication was exposed. And the total message communicated total, like per each MPU, is 1.75 megabytes. So yeah, I'm just again summarizing the core result. We can see how long it took, and we can also see the same result in the CSV file. So this is wrapping up the first exercise. That's downloading, compiling, and running like very simple ASTRA-sim